Hello and welcome to Petrosys webinars. My name is Jason Dixon and I'm the training coordinator here at Petrosys. Today I will be running through the Introducing the Lowest Closing Contours webinar. This webinar will be recorded, so you'll be able to log on to the Petrosys portal later on and view this webinar once you've had time to process it and upload that. So we'll go through a bit of how we're going to run through the course or the webinar. We'll run through an introduction, what the lowest closing contour feature is and what we can get out of that. Some of the input parameters that we need to input into the panel to get the outputs that we desire, what we're going to get out of the lowest closing contours task, and then I'll run through a demonstration setting it up, running it through and showing you how to use the different input parameters to get different outputs. And after that we'll run through some final thoughts. So, introduction. The new Petrosys feature allows us to generate a series of lowest closing contours or polygons that define our prospect closures or structures. So we can use this to define structures from our grids. We can also use the functionality to quickly and easily generate a series of prospects into a shapefile, and this shapefile will contain the polygon of the spill point, the area of that polygon, the height of the structure, and the Z value of that polygon, which is the spill point Z value. And it can be easily accessed through the surface modeling module using the menu option contour, lowest closing contour. And what we'll do is we'll run through how to set up and run this process using some various input parameters, and then we'll see what we can get out of that. So we'll have a look now at the input parameters that we can use. The first thing we need is the input grid. So we can use a Petrosys grid file or direct connects to third-party applications and pull grids in from those applications and run those. We can also use well or point data. So on the right here I've got a panel which is using the well data file well source. So we select the well data file that we want to use. We need to select the formation top that ties to our grid, and then we can also, under the formation, we can have the attributes tied to that formation. So here we need a lowest known hydrocarbon contacts, and dry holes or dry wells. We can use these, so we need a dry hole flag, and I'll show you how this is set up in the demonstration. We can also use faults, so we can use both leaking and sealing faults. So here we've got a fault file, and we have a group set up for sealing faults and a group set up for leaking faults, and we can use those. So when the contours go down and hit a sealing fault, they can continue to go down until they find an alternative spill point, whereas if they hit a leaking fault, that'll automatically invalidate anything below that, and anything above that can be sealing and used as a prospect polygon. There are also some economic parameters that can be used. So we can use minimum pool area and also minimum structural height to define anything that's small and not going to be economic for us to worry about. So if we can remove the noise. We have some other control parameters as well that we can use, so maximum column height. So for example, if we have a capillary pressure seal issue where we know that we can only generate a certain height of a structure before that oil column will leak or the gas column will leak through the seal, we can invoke a restriction here to not allow any structures to be greater than a certain height. We can also use a contour increment to speed up the process a little bit, so instead of running through it the predefined contour increment, we can increase that to make the process run faster. We can also choose levels of closure. This allows us to find the deepest structural spill point, and then define, if we want to say 10 levels of closure, we can find the next 10 levels above that deepest level. So then we can use those as P90, P50 and P10 inputs. And we can also use clipping polygons to restrict the area that we're looking at as well. Now the output parameters that are generated. We generate a shapefile which includes the polygons for each of the identified closure or the prospects, and these have the attributes tied to them. And we also can generate an XML report which can be viewed in a web browser and show the input and output parameters in one file. So each of the polygons that's generated in the shapefile has attributes associated with it. These include the Z value of the lowest closing contour or the spill point, the spill level, the column height of the structure, the area of the polygon, and this area is defined in the units of the Petrosys project. So in this one it's US feet, square US feet, and we also have the closure level. So if we've decided we want to have a list of structures above the deepest one, we can see which one we've chosen here. So this one is 9 levels above the deepest closure. Okay, now we shall run through a demonstration on how we can use this. So first of all, here we have our Petrosys grid that we'll be using, and then what I'll do is I'll just turn this to 100% translucency so we only see the contours that we are interested in. We can also use faults, so I can have my sealing faults and my leaking faults. So the sealing faults here are embedded in the grid, and we can overwrite those with any faults that we like. So I've turned on some red faults, which will be our leaking faults. So if I run these as leaking, any structure that intersects that leaking fault will not be validated. We can also have a series of wells. So I've got some wells here which we've chosen, and this is the height of the formation top, so that ties to our grid. And out of that well selection, I've got a list of wells here where I have lowest known hydrocarbons and the associated lowest known hydrocarbon depth. I have some hydrocarbon contact wells, so we know that at this level it cannot go any deeper than that level because we have a hydrocarbon contact at minus 2,850. And then I also have a couple of dry holes. So we've got these wells here. If these wells are in the closure, that closure cannot be any deeper than that intersection of that formation. So in my well data file, I've got for each of my wells, for the formation that I'm interested in, I've set up a few different parameters here which we've just seen. So this is an attribute tied to the formation, and here I've got my oil water contact, and I've got 2 wells with oil water contacts defined. I have lowest known hydrocarbons, and I have 2 wells with the lowest known hydrocarbon defined. And then I have a dry hole flag, so I've just typed in yes if this well is a dry hole. So now to go through how we set this up. We'll start off with just running a standard. Well, first of all, I'll show you how we launch this. We can start by going contour, lowest closing contours, and that will open up the panel which we can then fill out. So here I've got a few set up which we can run. I'll run these already so that we don't have to waste time running through each of these and running the process. So for this one, it's simply I've selected my grid and I've not turned anything else on, and I've not set any input parameters. I've just let the cell refinement stay as 10, and if I ran that, what I would see would be this grid here. Actually, sorry, be this grid here. So you see these little structures where we have small structures which are uneconomic, and the grid or the process has automatically found all of the closing structures within that grid. Now the next one is I want to set up some parameters. So I've got here, I've put in some minimum area. I don't want anything smaller than a certain size. So if I run that one, then I'll see this one here. So you can see that now we've got the dark blue over top. These small blue ones here, if I turn those off, will no longer be valid. We don't see those, so we can remove the noise. Now if I apply leaking faults to that, so far I've only run a grid with embedded faults. Now what I'm going to do is I'm going to turn on the fault set, and I'm going to use leaking faults, and I've selected a Petrosys fault file, selected the surface for that, and then selected the group of my leaking faults. And I've left in here a 5 meter, this time I put in a 5 meter contour increment and left that same minimum area just to remove that noise. So once we've run that one, we'll see this set here. So I've just turned on the faults that are leaking in red, and you can see now that we've limited the structures so that wherever it hits a leaking fault, it automatically will become invalid. So we've restricted our sizes of our pools. The next step is with our well data. So in this instance we're using dry holes. So under well data I would select wells, and here I can select my well data file or direct connect to any of my third-party connections. Select if I want a well data selection list. Select my formation top from my list, and then once I've selected my formation top, I select my dry hole flag. So here I've got dry hole, and as we saw in the well data file before, my flag was yes, so I manually type in yes here. And once we run that, I would end up with this list here. So you can see that we've got our 3 dry holes displayed. If I zoom in on this area, I've drilled one well here, but this blue line is the well path, and where that intersects the horizon, you can see there's a small area here which has been invalidated, but we have this up-dip potential. So even though we've drilled this well up against the fault expecting to get a closure and a success, we failed, but we have up-dip potential, so we can go back and have a look at potentially drilling a well up-dip of our dry hole. Another one that we can do next is our lowest known hydrocarbons. So what this does is it restricts the minimum size. So it will say everything in our lowest known hydrocarbon must be deeper than our lowest known hydrocarbon. So we can select, again, our well data file, our formation top, and this time we select the lowest known hydrocarbon attribute, select our attribute, and we can run that. And this time when we turn on our lowest known hydrocarbons, we can see that we've got a lowest known hydrocarbon here at minus 2,858, and you can see that I've turned on that attribute for the Z level, our spill point, and it's 2,869, which is deeper than our lowest known hydrocarbon. So that's told us that this is the maximum that we can find. So between our lowest known hydrocarbon of the well and that value there, we know that we're somewhere in the ballpark. And then hydrocarbon contacts. So we can display hydrocarbon contacts. So as with the lowest known hydrocarbons, again, with this time we'll select hydrocarbon contacts, and we can display that onto our map. And then we know that if we have a well with minus 2,850, we can zoom in, and if we click on this contour here, we can read off down the bottom that contour is minus 2,850, which matches up with our prospect polygon. So our prospect has generated a contour of minus 2,850. We can also run levels, so I'll just show you the levels one now. So if we run here, we've typed in that we want levels of closure as 50. So if I now turn on my lowest known hydrocarbons with levels, turn off the others, and I'll just turn off the grid now so that you can see now that we have a list of structures going down to our lowest spill point, which is our first one. Then we go several levels up until we either get to no higher levels or to the limit that we've specified. So then we can use those outputs. So if we edit those, we'll be able to see those in Spatial Editor. When we click on any of these, we can read off the values that we have tied into those as well. And also column restrictions. So if we look at the column restrictions, now I've set a maximum column height of 200. So if I look at my maximum column height of 200, I'll turn this one off. So, and we'll turn the grid contours back on. You can see that that is a 200 level, so that will be our size of our prize there for this area. So it's quite a good quick tool to quickly generate prospect polygons from our grids that we can then use in our volumetrics. We can export those, look at this area, put a buffer around those and run those in volumetrics and get a quick idea. If we have a prospects and leads database, we can use those as area depth pairs and plug those in to generate our distribution for our prospect. So now we should go back into PowerPoint and we'll finish off. So some final thoughts. The lowest closing contour feature allows the user to quickly and easily identify prospects in their grids, and we can use our fault data, our geological knowledge and our well data to constrain those limits and remove any uneconomic noise as well. This reduces the time spent reviewing grids manually for economic structures, so we can quickly run that, identify those and generate a list of areas that are required for further investigation. The shapefile outputs can then be displayed in the mapping and also in the 3D viewer to QC the data to QC our identified prospects, and we can also rank and high grade those opportunities for further investigation. So some other self-learning in Petrosys, so please don't forget that this webinar was recorded along with all of our other webinars, and these can be found under the Learn tab under the Petrosys portal. And we also have some more information on training within Petrosys, so you can go to the Petrosys website and click on the training tab and view all of the training courses available to you. And remember that if you want any specific training, that you can contact us at training@petrosys.com.au email address, and we can discuss some training options that may be relevant to you. So if you have any further questions, please let me know. And remember that you can log on to the Petrosys portal and look at all of the PDFs that can help you run through any workflows that we have available in Petrosys. Thank you for your time.